Okay. Okay, babe. Probably better that way.
Shut up. I moved in a week, baby.
Don't say that. Too much change! I gotta go. I don't care. Do what you please.
Alright.
Girlfriend doesn't matter.
Girlfriend will still be over at my new house. 10 minutes away. Instead of 5 minutes away.
Girlfriend's basically that deal.
10 minutes away instead of 5.
Girlfriend said you. See you, I guess, never.
Alright, I love you, baby. Have a good practice. Have a good kicks.
Text me if you like hanging out later.
After practice? Yes.
Bye, baby.
Bye. I love you. Hey. Come here.
What?
Come here.
I don't know my mom pictures. My mom pictures.
I love you, baby.
Now you want to dive up on me.
Yeah, we're just sitting over the last 15 minutes before I have to go try to clean the car.
So much.
Thank you, baby. Good practice. I think I might have left your moped keys out there.
Okay, we'll check. I'm blowing this pocket. Let's dance.
Alright.
So can everyone hear me? Yeah. Okay, good. So I'm a TA. Today I will host this review section, and we will go over all this. I believe there are 24 questions, and the exam will be 20 multiple choice questions. I'm not sure whether it's multiple choice question or not. Let me check. Should be there are only 20 questions, and the format will be exactly similar to the midterm one. Okay, and the exam time will be the class time next Wednesday from 1:30 to 2:45. Okay. So let's talk about those questions. So for question 1, we already know this annual percentage rate equal to 11%, right? This is the annual percentage rate, APR. And the question asks us, what is the effective annual rate given the annual percentage rate equal to 11%, which means we need to convert this APR to EAR, right? We have a formula to do that. The EAR would equal to effective annual rate would equal to 1 plus the APR divided by M, then with the power of M minus 1, right? So here the M is the number of compounding periods in a year, okay? So now we can simply plug all the number in. The APR equal to 11%, right? 11% divided by, since it's a quarterly compounded, so the M will equal to 4, right? Here it should be 4 minus 1. Then you can find out what is the effective annual rate in this case. So equal to 11.46%. Okay, so the correct answer should be C. So in this case, we're simply converting APR into EAR, and sometimes you basically should also know how to convert EAR to APR, right? So this is question 1. Question 2 is very similar. In this case, you have 4 investments, right? You already know their APR, but their compounding interval is different. A is annual compounding, B is daily compounding, C is quarterly compounding, and D is monthly compounding. Basically, we'll use a similar formula as we used in question 1. Okay, so this formula. Okay, you need to use this formula to do the calculation. Okay, you should remember it actually. This one is important. You will use this formula to do the calculation, but here, a little bit complex here is, now we have different compounding intervals. For the first one, it's annual compounding, right? So the M should equal to 1, right? Should equal to 1. If it's daily compounding, the M should equal to 365, right? If it's quarterly compounding, then M should equal to 4, as the case in question 1. If it's monthly compounding, then the M should equal to 12, right? Or if it's weekly compounding, then M should equal to 52, okay? So simply apply all those numbers, and then you can easily find out for investment A, the effective annual rate would equal to, let me use a different color, would equal to 6.9030%. So this is for A, okay? For B, the effective annual rate would equal to 6.9280%. For investment C, it will equal to 6.9530%.
Damn, so I already
For the last
scheduled
one,
like a DoorDashing time and shit, but what if I just came by the hotel and set this up for like 10-15 minutes?
Right? And you need to take the lowest one, which one's
Okay.
lowest?
Yeah, sorry, bro. We canceled the reservation after
This
that.
one's lowest. Right? So
Yeah, that's through an app. No, it's all good.
Okay, use this formula. Use this formula. Find out what is the N, then you can easily figure out what is the price. Okay, so this.
So everything in the blue.
All right, yeah, I'll hit you up at like
formula, and that's
probably like 4ish.
Blue. This part.
All right, bro. Yeah, my bad. Sorry about that.
Yes, it's the result after you apply this formula.
Yeah.
Oh, okay.
And here I also figure out the N.
Well, at least you had a
figure
out of Dukes. That place pretty cool, huh?
Actually use, right?
Yeah, it's pretty cool.
Yeah.
I like the music and stuff.
Yeah, dude, I'm just surprised they don't have more bars like right on the beach out here. Like I would have thought that would have been a huge thing, but like I think Dukes is pretty much the only one.
Yeah, I wonder why.
Okay, this is the N.
Yeah.
So this is the N. Green one is the N.
But yeah, so if you can, still try to go to the deck though, because that place is sick.
Okay, if I can get a reservation for where you got meet up.
Yeah, let me know what time it is.
Okay, sounds good.
Okay. All right, bro.
A check costs $111,000 is paid off in monthly installments over 4 years with the annual percentage rate equal to 8.1%. After 3 years, the owner was to sell the check. The question asks us, what is the closest amount from the following list that he needs to pay on his loan before he can sell this check? So to answer this question, we can simply first draw a timeline. Since in the original contract, there are 4 years, right? And there's a monthly payment. So overall, actually, there are 48 months, right? Because there are 4 years. And after 3 years, if he's here, he wants to sell this car, sell this check, right? The question asks us, if he's here, if he's in year 3, what is the remaining balance? He still need to pay back to the lender or the bank, right? So this is the basic question. And in fact, based on the original contract, in each month, he needs to pay some money, right? He needs to pay some money. Each month, he needs to pay some money. But if after 3 years, actually, he already finished this part, right? He already finished this part. So actually, we can simply ignore the first 3 years cash flows because he already completed it, right? The remaining part is only the 1 year cash flow from year 3 to year 4, right? This remaining cash flow, and actually there should be 12 cash flows, right? Because within 1 year there are 12 months, and in each month he needs to pay back. He needs to pay some money back. Okay, so here should be 12. Okay, 12 months. So in this case, basically we are simply calculating the present value of the future cash flow of these cash flows, right? These cash flows. So basically, we can use our financial calculator. N would equal to 12 because the remaining cash flow it's a 12 months cash flow, right? And the interest rate actually is given would equal to 8.1 divided by 12, right? It will equal to 0.675%. The period of payment, we didn't know that so far. The present value is what we want to calculate, and the future value actually is 0. It simply means in the end, you pay all the money back. So in this case, to calculate the present value, we need to figure out what is the period of payment, right? To calculate the period of payment, actually, we can go back to the original contract. The original contract tells us that this cash flow need to pay, this money need to pay back in 4 years. So of N, it should be 48, right? So this is the original loan contract. And the interest rate is similar. This amount, the present value actually should be 111,000, right? The period payment is what we want. Again, future value should equal to 0, right? So by doing that, you can easily calculate the period payment should equal to negative 2,715.0478. Okay, so by contract, for each month, you need to pay this amount. Okay, by contract, for each month, you need to pay this amount. And if you are in year 3, if you are here, there are 12 of this kind of cash flow waiting for you to pay in a year, right? So we can simply plug in negative 2,715.0478 here, and then we can easily figure out what is the present value, right? The present value will equal to 31,195. Okay, so the correct answer should be C. The correct answer should be C. Okay. So final question. Good. Okay. Question 4. In question 4, given the nominal interest rate and the inflation rate, we need to calculate the real interest rate, right? The real interest rate, we have a formula to deal with that. The real interest rate would equal to the nominal interest rate minus the inflation rate divided by 1 plus the inflation rate. So this is a formula you can find in your textbook. So we simply plug all the number in, 4.5%, which is nominal interest rate, minus 2.8, which is the inflation rate, divided by 1 plus the inflation rate. Right? By doing that, you can easily calculate. The correct answer is D. Okay, the correct answer is D. For this question, is simply apply the formula. Question 5. We have a coupon with the face value. Excuse me. We have a bond with a face value equal to 10,000, right? So it's a face value. It also tells us the coupon rate equal to 9%. And this coupon is paid semi-annually. The question asks us, what is the coupon payment for this bond? Again, we have a formula to deal with that. The coupon payment would equal to the face value multiplied by the coupon rate divided by the number of coupon payments in a year. So let's use M to represent it. So in this case, we can simply plug all the number in. Here, 10,000 face value multiplied by the coupon rate, giving information 9%, divided by 2, because it's the semi-annual coupon payment, right? By doing that, you can easily calculate the correct answer should be B. Okay, so this is also very simple. Question 6. We have a zero coupon bond with a face value equal to 1,000. It has 10 years left until maturity. The year to maturity equal to 10.2%. the question asks us what is the bond price. So this case again, we can use a formula. The bond price would simply equal to the present value of its future value or its face value, right? Would equal to face value or face value divided by 1 plus R with the power of n. Right? In this case, the face value or the future value is 1,000 divided by 1 plus 10.2%, which is the discount rate, and n should equal to 10 because there are 10 time periods, 10 years, right? So by doing that, you can easily calculate the correct answer should equal to 378.60. So should be D. Okay, so for zero coupon bonds, you can either use the formula or calculator to do the calculation. But for the coupon bond, my suggestion is directly use the financial calculator because it's much simple. Okay. Here we have an example of coupon bond. We have a bond with a face value equal to 5,000, the coupon rate equal to 5.7% paid semi-annually, and it has 10 years to maturity, and the year to maturity equal to 6.4%. If the interest rate fall and the year to maturity decreased by 0.8%, the question asks us what happened to the bond price. So if we want to check what happened to the bond price, we simply calculate what is the price before the interest rate change and what is the bond price after the interest rate change, right? So let's check what information do we have. So first of all, we already know the number of periods for this bond, right? It will equal to 10 multiplied by 2 equal to 20, right? We also know the period payment. The period payment would equal to the face value 5,000 multiplied by the coupon rate 5.7% divided by 2. So the period payment or the coupon payment for half year would equal to $142.5. Okay. And we also know what is the face value. Face value is always giving information 5,000, right? To calculate the bond price, one information we still need to know, which is the year to maturity or the discount rate. So let's check. First, let's check before the interest rate change. Okay. Before the interest rate change, the year to maturity equals to 6.4%, right? Based on this information, you can easily figure out the discount rate would equal to 4.6 divided by 2 equals 3.2, right? Now we already know our earn, we already know our period payment, we already know our discount rate, interest rate, and we also know our face value. Then we can easily figure out what is our present value, right? What is our present value? And this present value would equal to negative 4,744.3939, which simply means the bond price would equal to this amount, right? Okay, so this is a bond price before the interest rate change. Now let's check what is the bond price after the interest rate change. Okay, after interest rate change, the year to maturity will becomes 6.4%. Since it decreased by 0.8%, right? You simply minus 0.8%. It will give 5.6%, right? So year to maturity after the interest rate change equals to 5.6%. Based on this information, we can also figure out the interest rate would equal to 5.6 divided by 2 equal to 2.8, right? So 2.8 is the number you need to put in your financial calculator, okay? So with this information, we can figure out the bond price after the interest rate change would equal to 5,037.8909, okay? So now your job is to simply compare the price before the interest rate change and the price after the interest rate change, okay? And as we can see, the price actually increased, right? The price increased by how much? by 293.5. So the correct answer is D. Okay, so final question. Good. Okay, so let's move on. So question 8. Now we have a company has a bond outstanding with a face value equal to 5,000, and it has 8 years to maturity. The bond certificate indicates that the coupon rate equal to 8.2%, and this coupon payment will be made semi-annually. Assume the bond price today is $4,541.35. The question asks us, what is the year to maturity? So again, if it's the coupon bonds, then simply directly use the financial calculator because it's much, much simpler. Okay, so let's first figure out what is N. Our N would equal to 8 years multiplied by 2, right? Because it's paid semi-annually. The coupon is paid semi-annually. So N would equal to 16. Our interest rate, actually the interest rate is what we want to calculate. So let's put a question mark here. The present value is today's bond price, right? So we put it here, negative 4,541.53. Period payment, again, you can use a formula to calculate the coupon payment. Face value multiplied by the coupon rate, 8.2% divided by 2, paid semi-annually, right? So it will equal to 205. Face value, again, is always giving information, 5,000. Right? By doing that, you can easily figure out the interest rate. This one would equal to 4.9426. Okay, so this interest rate actually is the semi-annual interest rate, right? But we know that year to maturity, this one is quoted as APR, is the annual rate, right? We want to convert this semi-annual interest rate into annual rate. Simply use this one, semi-annual interest rate multiplied by 2. Then you convert it to annual rate. Okay, so that will give us the year to maturity equals to 9.8852%. Okay, so the correct answer should be D. So this question actually, the tricky part for this question is that you may forget the last step, do the conversion, right? You need to convert the semi-annual interest rate to